are up with another presentation to explain the systematic qualitative analysis of organic compounds. This is a team effort by me, Shruti Goel, and my partner Devika JAYAN. Before actually proceeding with our topic, I would like to express my gratitude to our principal, Dr. Manoj Kumar Khanna, and to the organic chemistry faculty of our department for motivating us to take the initiative of effective learning. To begin with our presentation, first of all, here is a quick recap of what systematic organic analysis is. We all know that we have a huge number of organic compounds available around us. So, to identify a particular organic compound becomes an important task, and qualitative organic analysis helps us in this. Hence, as can be seen, to identify and analyze an organic compound through a fixed stepwise procedure is known as systematic qualitative analysis. With advances in technologies, though we have certain techniques that can help us reduce our time of identifying the compound, still the classical qualitative analysis is relevant both for our academics and for our knowledge. Stages or steps involved in it are: first, the preliminary tests, which involves certain initial steps to get the rough idea about the given unknown organic compound. This involves determination of physical state, its color and odor. A note should be taken that odor and color of a compound may be illusionary, and hence no certain inference can be made from this. Still, these might help us in our analysis and hence are performed. Ignition test is also an important preliminary test which helps us to identify if the compound is aromatic or aliphatic. Solubility test helps us to know if the compound is acidic, basic, or neutral, which helps us in identifying the unknown organic compound. And the tests for unsaturation, that is Bayer's test and bromine solution test, are also important part of preliminary tests, as these helps us to know if the compound is saturated or unsaturated. The next step is detection of extra element. Any element other than carbon, hydrogen, and oxygen are known as extra elements, and their detection helps us in identifying the functional group that may be present. The third and one of the most important step is identification of functional group, as it is the functional groups that governs the chemical properties of the organic compound. Hence, the detection is very essential and helps us to know the compound. The fourth step is determination of physical constants, that is the melting point if the compound is solid and the boiling point if the compound is liquid, as this is helpful in narrowing the list of probable compounds. To further determine the organic compound, a suitable derivative is formed, followed by the determination of its melting point. This helps us to find the unknown organic compound. Proceeding with our unknown organic compound, first, the preliminary tests were performed. The physical state of the compound was found to be liquid, and hence we can infer that the compound might be an alcohol, ester, or carbonyl compound. The compound was found to be colorless when was checked for its color. The odor of the compound was found to be characteristically pleasant, which infers that the compound may be alcohol, ester, or carbonyl compound. Further, ignition test was performed. The compound was taken in a spatula, and on introduction to the oxidizing flame of the burner, that is the blue flame, a sooty flame was observed, which suggests that the compound is aromatic as it has more carbon content. After that, the solubility tests were performed by dissolving a small quantity of the unknown compound in these solvents. The compound was insoluble in water, which suggests that it might be higher member of functional group and has bulk. Second, the solubility was tested in sodium hydroxide, which is a base, and the compound was insoluble in it. This suggests that the compound may not be acidic in nature, which is further confirmed by its insolubility in sodium bicarbonate solution. Hence, the compound is not acidic in nature. Fourth, its solubility was tested in dilute HCl and the compound was insoluble in this as well, which suggests that the compound is not basic also, and hence the compound is a neutral compound. Its solubility was tested in ethanol also, and the compound was soluble, which suggests that being an organic compound, the compound is non-polar. Then we proceeded for the tests for unsaturation. We first performed the Bayer's test, that is alkaline potassium permanganate solution was added to the unknown organic compound and no color change was observed, that is no decolorization took place, which suggests that unsaturation is absent. This was further confirmed by bromine solution test. When bromine solution was added to a small quantity of the unknown organic compound, no decolorization of brown color was observed, which suggests that the compound is not unsaturated, that is unsaturation is absent. Moving ahead, we do a second step, that is detection of extra element. The organic compound was fused with sodium metal to form the Lysines extract, which was further treated with different reagents to check for the detection of extra element. No extra element was detected and hence we can infer that nitro, amino, amido or halogen groups are absent in the given unknown organic compound. Now I would like to request Devika to please continue with her part.
Thank you, Shruti. The third step of systematic analysis of the organic compound is the functional group detection. We start with the carboxylic acid, followed by alcohol, phenol, carbonyl compound, and ester. So starting with test for carboxylic acid, the first test is the litmus test. Here we add a 2-3 drops of blue litmus solution directly to the compound or to the aqueous solution of the compound. If there is a change from blue to red, we say that acidic group is present. But we here observe that no change in color, that means carboxylic acid group is absent. To confirm this, we do a second test, that is sodium bicarbonate test. Here about a 2 ml of cold saturated solution of sodium bicarbonate is taken in a test tube and we add a pinch of organic compound. Efferences, then carboxylic acid group is present, but here also we observe that is no brick efferences is observed, so that means carboxylic acid group is absent. Then we move to the next test, that is test for alcohol. Here we can perform a sodium metal test, can test. In sodium metal test, we take a 1-2 ml of the compound and we add a small piece of sodium metal. And when there is a brick efferences or due to the evolution of hydrogen is observed, then we can say the alcohol is present. But usually we don't perform this test in the laboratories. So that's why we didn't mention here. So in laboratory, we perform ferric ammonium nitrate test, that is the CAN test. Here we take in test tube, we add a 2 ml of ferric ammonium nitrate reagent and slowly add with shaking 1-2 drops of the liquid compound or solid compound. Then there is a color change from yellow to red. That means hydroxyl group is present, alcohol is present. Then the second test is iodoform test. Usually we perform this test for alcohols to confirm whether our alcohol is containing CH3CHOH group. Also, this test is performed for methyl ketones. Here we dissolve 0.1 gram or 4-5 drops of a compound in 2 ml of water or dioxin for water insoluble compound. Then we add a 5 to 6 ml of 10% sodium hydroxide solution followed by iodine solution dropwise with continuous shaking till a light brown color persists. Then we keep the test tube in the room temperature for 10 to 15 minutes and note the observation. If there is a formation of pale yellow precipitate, we can say that CH3CHOH group or methyl ketones are present. But here we observe that no precipitate of iodoform is obtained. So our inference is CH3CHOH group is absent. Next, we move to the fourth step of systematic analysis, that is the detection of physical constant. Here a given compound is liquid, so we proceed by detection of boiling point, that is by simple distillation method, and we observe that the boiling point was found to be 204 degrees Celsius. So we can infer that the given organic compound is an aromatic alcohol with boiling point 204 degrees Celsius. From this all above observations and inference, we form a table of probable compounds. That is, whether a compound may be a benzyl alcohol or 1-phenyl ethanol. That is, these two compounds have a near boiling point to a compound. Next, to confirm this, we proceed for a next step, that is step 5, the preparation of derivative. As we know, this is an aromatic alcohol, so the best derivative for the aromatic alcohol is oxidation. Here we reflect a mixture of 1 ml of aromatic alcohol, 1 gram of sodium solid potassium permanganate, 0.5 gram of sodium carbonate, and 20 ml of water in a 50 ml round bottom flask. We heat the contents directly on a wire gauze for 30 to 35 minutes, cool, and add saturated solution of sodium bisulfate. We filter and add concentrated HCl till acidic and filter the precipitate of acid. Here we get observation is we get a crystalline white solid precipitate of oxidized product. The next step is the melting point of derivative. As a derivative is a solid compound, we measure the melting point. We take melting point using a Gelder's method, and we found that the melting point range was found to be 119 to 121 degrees Celsius. Now, from the derivative and the melting point of the derivative, we again form a probable compound table where benzyl alcohol is having a melting point of the derivative. Its derivative is 120 degrees Celsius, and 1-phenyl ethanol is having a melting point derivative of 21 degrees Celsius. From here, we can clearly see that our given compound is benzyl alcohol because its derivative and its compound boiling point is same as what we observed. So in the result, we say that the given organic compound was identified as benzyl alcohol. Its IUPAC name is phenyl methanol. And here its structure. So now Shruti will proceed.
So now, as we all are chemistry students, we should know what was actually the chemistry involved behind all these reactions. So while performing the test for alcohol, our observation was that benzyl alcohol, as we have now identified the compound, on reacting with steric ammonium nitrate, leads to the formation of this red colored complex, which is formed by the removal of the acidic proton of the alcohol, and it then forms a complex with the steric cerium ion. The second reaction is the preparation of derivative. Since benzyl alcohol has its benzylic position as highly reactive, when it reacts with KMnO4, that is potassium permanganate, in alkaline condition, it undergoes oxidation reaction. So as we all know, primary alcohols, when they are first oxidized, they convert into an aldehyde, and then on further oxidation, that is, if the oxidation is performed for a prolonged duration, the formation of benzoic acid takes place, and so is what happened in this reaction. Benzoic acid was formed, and later on detection of the melting point, it can further be identified as the compound has a melting point of 121 degrees centigrade, and so is the melting point of benzoic acid. Along with that, The other products obtained were CO2 and MnO2. MnO2 leads to the formation of brownish precipitate in a very less amount, yet these can be observed.
So our alternative derivative is 3,5-dinitrobenzoate. Here the reaction is between the benzoyl alcohol and 3,5-dinitrobenzoyl chloride. So for the 3,5-dinitrobenzoate, we first prepare for the 3,5-dinitrobenzoyl chloride. Here we take in a dry china dish, we take about 2 gram of 3,5-dinitrobenzoic acid and we add approximately a 4 gram of PCl5. We mix the contents with the help of a glass rod till a paste is obtained. If paste not obtained, heat the reaction in mixture in the water bath. The liquid paste so obtained is 3,5-dinitrobenzoyl chloride. From this prepared 3,5-dinitrobenzoyl chloride, we proceed for the preparation of 3,5-dinitrobenzoate. In a dry conical flask, we warm the prepared 0.1 gram of 3,5-dinitrobenzoyl chloride on a sandbath. Then to this we add 1-2 ml of the given alcohol. We heat the contents on the sandbath for 5 minutes. We cool it in the ice cold water and filter. We wash the solid with the sodium carbonate solution to remove excess of 3,5-dinitrobenzoic acid. We crystallize it and we determine its melting point. When we determine its melting point, we observe that 113 degrees Celsius was found. Now we look for the chemistry, the reaction evolved. Here it is the reaction between an aromatic alcohol and 3,5-dinitrobenzoyl alcohol. So here there is a addition of the oxygen of the alcohol to the carbonyl carbon of the 3,5-nitrobenzoyl chloride. Then there is a followed by a elimination step. Then we get the product of 3,5-dinitrobenzoate of benzyl alcohol. Thank you.
So these were the references that we used while making this presentation and while studying. I hope that this will help us in studying and learning organic analysis in a better way. Thank you.